Hi everybody! I have made this supplemental video because I'm afraid that some of you may be feeling like this guy right now. And this is following, or I'm assuming that you've already watched Chapter 6, the recording for Chapter 6, and now you've come to realize that there are certain concepts that have all kind of jumbled together in your mind. And I understand the source of confusion, and I'm hoping that this is going to help you, okay? But let's say after watching this little mini video, you're like, this does not help. I'm still really baffled, confused, whatever. Don't get teary-eyed again. For a couple of reasons. One is I'm still here to help you. So if it doesn't make sense, I can sit down with you and we can go through it different ways and try and connect on some level. But even if it never fully connects for you, I don't want you to think that that's it. I'm never going to get an A. It's out of the question. That's not the case at all. I would love for all of you to understand what I'm about to explain to you, but it's not, again, do or die. All right. So where is the confusion? Well, I've said many things up to this point in the class, but there are 4 things that I've said that might have you confused. Early on, when we started to learn about properties of the mean, we said if you add up all the x minus x bars, they add up to 0. That was one thing I said. Now, this is an x bar. Remember that. So if you add up all your x minus x bars, let's say in a data set, they're going to sum to 0. And you might have got that. I don't know. But we'll go over it. Then I said when you take the mean of the means, this number equals the population mean, mu, which is not going to be 0 unless mu happens to be 0. All right, this is if you exhaustively sample. And we talked about this when we were looking at biased and unbiased estimates. And then I said, well, if you add up all the differences between x bar 1 and x bar 2, so if you go x bar 1 minus x bar 2, if you add them all up, those will sum to 0. And this was something I think I might have talked about when we were talking about the sampling distribution of differences. And finally, I said, when you take the mean of all these differences, x bar 1 minus x bar 2, this number will equal mu, which is always 0 if you exhaustively sample. So now your head's probably spinning, right? And you're saying, wait a second, this adds to 0, this adds, or this equals mu, this mu equals mu, which is not necessarily 0. This one sums to 0, and this one always sums to 0. So you're kind of way confused. And I get that. So here, oops, we'll solve the mystery. These guys weren't supposed to be here, but just ignore them, okay? So there are 2 concepts we've learned about in class that illustrate that the mean is the center of gravity. All right. So when we were looking at simply a set of raw scores, if we were to find out this distance, okay, so if we do x minus x bar for the entire set of raw scores, they will sum to 0, and that's because the mean is the center of gravity. And I have a little, oops, oh, sorry, let me back up. I was not supposed to be there yet. I do have a diagram to show this to you, okay? But this is what we learned early on. We just, remember the teeter-totter? We said if you subtract every x from the mean, those that are less than the mean will be negative numbers, and those x's that are greater than the mean will be positive numbers. And if you add them all up, you get 0. Then more recently, when we talked about the sampling distribution of differences, if you found the difference between 2 sample means, so here you have a mean for sample 1, a mean for sample 2. Okay, so subtract them, you're going to get a number, right? Well, if you were to add them up, all of these numbers, right, you subtract them, add them all up, you're going to get 0. Don't worry, I'm going to explain that again to you, okay? So these 2 concepts are going to help us to understand that the mean is the center of gravity. And then it's time for this. These 2 things are going to help us to understand when an estimate is unbiased. And you probably recall that when we learned about the mean, x bar, we said that that's an unbiased estimate. And that's because if you exhaustively sample, half of your means are going to be overestimating mu, and the other half are going to be underestimating mu. And if you were to average them all out, the underestimates cancel out the overestimates, and you're left with whatever mu equals, which isn't 0 unless the mu happens to be 0. All right, so we're going to review that. And then there's this one. Oh, that got cut off a little bit. When you take the mean of all the differences, okay, so remember, this is the difference between x bar 1 and x bar 2. So x bar 1 came from population 1, x bar 2 came from population 2. You subtract them, that's the difference. All right, so if you take the mean of all of these, just like up here, the number is going to equal mu, because half of them are overestimating mu and the other half are estimating mu. Are underestimating mu. So the overestimates cancel out the underestimates and we're left with mu, but I'm going to show you this mu is always 0. Okay? So these are the 4 things that I have said that could be making you a little teary-eyed. And so let's start with them. We're going to go in the order that you learned them. The first one, x bar is the center of gravity for a sample of raw scores. Or we could even do this by saying mu is the center of gravity for a population of raw scores. You know, the mean is the center of gravity, whether we're talking about a sample mean or a population mean. Okay, so here's an example where we just have, some numbers here. This is, let's say, our sample, and 13.5 is the mean. I know this because I got out my calculator, okay? So this is the mean. And we said that one of the properties of the mean states that if you were to take each score, like 11, and subtract the mean, well, 11 is smaller than 13.5, so that's going to give you a negative number, right? And then if you do 10 minus the mean, you're going to get another negative number because 10 is smaller than 13.5. Same thing here, 9 minus the mean, 8 minus the mean. These are all going to be negative numbers. They're negative distances, right? This is a distance between a raw score and the mean. And they're all going to be negative. Now this one, this side over here, if you go x minus the mean, well, these x's are larger than the mean. So when you go 16 minus 13.5, you're going to get a positive number, a positive distance. And that's true with all of them, right? So these are all going to be positive distances, and all of these are negative. Now, if we were to add them all up, these negative distances are going to cancel out the positive differences or distances. All right, so if this is negative 13, this is going to be positive 13. When you add them all up, you get 0. And we went through and we did an example where you actually saw that happen, okay? So this shows us that the reason why it's happening is because the mean is the fulcrum. It's balancing the weighted distance of these scores with the weighted distance of those scores. So if this is negative 13, this is positive 13, and everything is nice and balanced. When you add them all up, you get 0. Okay? So that's what this is saying, right? Add up all the negatives and the positives, they cancel each other out, and when you do the addition, you're going to see you get 0. And this was a reason why we learned you have to get variance first. If you want to know the average distance that scores are to the mean, you're going to have to get the average squared distance first. That's variance. The average squared distance scores are to the mean. So you're going to square every single distance here, so that way you get rid of all negative numbers. And then once you have the variance, you take the square root, and that gives you standard deviation. Okay? All right. Then we learned x bar is an unbiased estimate. And what that means is that if we were to exhaustively sample, half the time we would get x bars that are overestimating mu. Okay, so let's say mu is 25, then half the time we're going to get x bars greater than that. But the other half the time, we're going to get x bars that are less than mu. All right, so here, if we were to add up all of our x bars, so the 30, the 32, the 20, the 18, well, they're not going to add up to 0, right? These are just estimates. They're not distances. They're not difference scores. They're just estimates. All right, X bar is estimating mu. So if we were to add up all of our estimates, 30 plus 20 plus 32 plus 18, we're not going to get 0. All right, I mean, there's a way we could get 0, but only if mu is 0. But I don't want to get into that right now, okay? So we're just adding up X bars. That's it. We're just adding up X bars. And that means that the sum will not equal 0 in all probability unless this happens to be 0. Now, if you do add them all up, all right, what you're going to do, or what you're going to see, is that the overestimates will eventually cancel out the underestimates, so that if we were to take the mean of all these numbers, so take the mean of 30 and 20 and 32 and 18, you will get mu. You'll be left with this. Now, I don't know, I just made up these numbers. I didn't get a calculator to see if this will actually equal 25, okay? So don't try and figure that one out, all right? But I'm just saying these are going to be numbers that are either going to be larger than mu or smaller than mu, but they're not distances. They're not, x minus x bars or anything. So when you add up just these numbers and then take the average, what you're going to find is the average is right here in the middle. It's mu. That's going to be what you're going to be left with, is mu. And that works as long as you exhaustively sample, and it shows us that X bar is unbiased. Half the time you're going to overestimate, and the other half the time you're going to underestimate. But the overestimates will balance out the underestimates, and you're going to be left with mu. Okay? Now, let's look at this one. This mu sub X bar 1 minus X bar 2, this is a mean, right? Mu is a mean. What is it a mean of? Well, it's a mean of the sampling distribution of differences. That's something we just learned about, the sampling distribution of differences. And so this is simply just the mean of that distribution. Well, like any other mean, it's the center of gravity. Only this time it's not the center of gravity for a set of raw scores, right? It's not the center of gravity for a sample or a population. It's the center of gravity for this distribution. All right, it's a distribution showing differences between X bar 1 and X bar 2. All right, and so just like when we learned about the center of gravity for a simple X bar, all right, remember we put X bar here a few slides ago? Well, now it's not X bar we're looking at, it's the mean of this distribution, so it's mu. All right. And then instead of looking at raw scores, right, we had raw scores plotted on the x-axis. Well, these are just going to be differences between X bar 1 and X bar 2, right? If we look over here, remember how we got those? We said we start off with two populations, and we're going to assume that those two populations are identical, all right? And then from population 1, we're going to get a sample. We're going to calculate X bar 1, so that's the sample that came from this population. And this is the sample that came from this one, all right? Then what we're going to do is we're going to subtract them. So X bar 1 minus X bar 2, and we're going to plot it. So this is just showing you an X bar 1 minus X bar 2, okay? And this one is showing you an X bar 1 minus X bar 2. And this is the center of gravity. This is mu. Now when we subtract this one, this number, because it's going to be a number, when we subtract it, this number from this mean, we're going to get a negative distance. And then same thing, if we subtract this number here, this difference between 1 and 2, it's going to be a number that is greater than the mean. All right, this distance is going to be positive. All right, and so again, the negative distances are going to be balanced with the positive distances, because we know the mean is always the center of gravity. It's the balance point. So negative distances are going to be the same value, if you will, as the positive distances. So if this is negative 13, this is positive 13. And when you add them all up, they sum to 0. Okay, so again, if we wanted to calculate the standard deviation of all these numbers here, we would need to get variance first. We'd have to square all the numbers we get here. right? Each one of those would have to be squared. Then we add, then we add them up. Sorry about that. And divide by however many we have. And then take the square root. So we get standard deviation is the square root of variance, right? Get variance first, take the square root, that gives you standard deviation. Okay, so again, this is just like saying x bar is the center of gravity for raw scores. We're saying mu, and then this is the mean of the sampling distribution. This is also the center of gravity. And instead of raw scores, we're just plotting differences. It's still the center of gravity, which means when we add up the negative and the positive, we get 0. Okay. But now I want to show you why this mean here is always going to be 0. All right. When we learned about the center of gravity for x bar could have been any number, right? We could have been anything. But when we're talking about the sampling distribution of differences, this mean is always going to be 0. And here's why. All right, so remember, it starts off with the assumption that you have two populations that are identical. mu1 equals mu2. There's no difference between them. Now we sample from each distribution, and you know by now that when you sample, you're going to have sampling error, right? It's a given. So we get a mean here. It's not going to be equal to mu1, not exactly, all right? It's going to be off because of sampling error. And same thing here, we're going to get a mean, we're going to take a sample, get a mean, and this one's going to be off as well because of sampling error. So you're not going to see that this is identical to that. All right, so both of them, x bar 1 and x bar 2 are going to, almost certainly going to be off by some amount. Now, that means when we subtract them, we're going to see a number that's not 0 in all probability, right? Because we said this is going to be off, this is going to be off. So when we subtract them, we should get some number. If there was no sampling error, x bar 1 would equal mu1. If there was 0 sampling error, x bar 2 would equal mu2 if there was 0 sampling error. And if there was 0 sampling error, that means when we subtract them, we would get 0. X bar 1 minus x bar 2 would equal 0 because they are the same number. So if mu1 was 10, and mu2 is 10, that would mean x bar 1 is 10 if there was no sampling error, and x bar 2 is 10 if there's no sampling error, and 10 minus 10 is 0. Okay, so if there's no sampling error, when you subtract x bar 1 and x bar 2, you get 0. But that's not real life. Real life has sampling error. So what we're now going to see is that half the time when you subtract them, x bar 1 is going to be smaller than x bar 2. And you're going to get a negative difference. But the other time, x bar 1 is going to be larger than x bar 2. And you're going to see a positive difference when you subtract them. Okay? So here is a picture of the sampling distribution of difference. Now remember, this is a difference score. It's the difference between two sample means. It's not a raw score. All right? Similarly, this is a mean, but it's the mean of all of these differences. Okay? Now, what do we know about, oh, this is a mistake. I'm sorry, that should say unbiased estimate. Sorry, please make a note of that, okay? This should say unbiased. All right, so what do we know about this? All right, this is an estimate. What is it an estimate of? Well, it's an estimate of mu1 minus mu2, right? X bar 1 is estimating mu1. X bar 2 is estimating mu2. So this is just an estimate of what it would be if we had the parameters. All right, now this is an unbiased estimate. Okay, so cross that out, it's unbiased. All right, so what does that mean? Well, it means that if we start off with the average, and I'm going to come back to this and explain some more why it's 0. But if we started with this and then we took estimates using x bar 1 minus x bar 2, half of them are going to be positive differences. You're going to get a positive answer, like +3, for example. But the other half are going to be negative differences. That happens, remember, when x bar 1 is smaller than x bar 2. So half of the differences are going to be negative. For example, negative 3. Well, x bar 1 minus x bar 2 is an unbiased estimate. That means that if you were to average these out, all right, average them out, you are going to be left with whatever it is in the population, in other words, mu, okay, whatever this is in the population. And again, it's always 0. So maybe the trickiest part of this is understanding why the mean of the differences should always be 0. Well, it's always 0 because, remember, we started with the assumption that our two populations are identical. So when we sample from each and calculate x bar, we're going to see some difference. But it should be, for all intents and purposes, most of them are going to be pretty small differences. If it's true that our two populations are identical, then when we subtract their two sample means, one from population 1, one from population 2, this should be a very small number, all right? And it will be negative, all right? So maybe negative 3, negative 2, negative 1, but we should see pretty small numbers. And over here, we should see pretty large numbers. Not large, pretty small numbers, but positive, right? So when we subtract x bar 1 minus x bar 2, we're not expecting to see big differences between them if mu 1 is the same as mu 2, but you do expect to see some difference, and these will be positive numbers. So these are small negative numbers, and these are small positive numbers, right? And if you were to take the average of all of them, they would give you 0 here. These are negative distances. Remember, they're not raw scores. These are different scores. These are negative distances. These are positive distances. And so when you add them all up, you get 0. Okay? So again, it's based on, this becomes 0 here because it's based on the assumption that mu 1 and mu 2 are identical. So that means x bar 1 minus x bar 2, you should in theory get a small number, but this will be a small negative number. This will be small positive numbers. And if you were to average out all the numbers here, so we're not saying sum them together, we're saying average them out, just like down here. If you take the average of all these numbers, you are going to get 0. All right? Okay, so I hope that helps. Again, it might be something that you're going to have to sort of watch a couple of times to make sure you're getting it. And again, if you are not getting it, you're going to miss some questions on an exam or a quiz. But if this is the only thing that gives you some grief in the entire class, you're doing awesome. This is not a break all, okay? End all, break all, whatever that expression is, okay? If you have any questions, let me know. And yeah, that's pretty much it.